Thank you for joining us today for our DB2 user group session. My name is Amanda Henley. I'm the managing editor at Planet Mainframe and your host for today. We've got a great session. I think it'll be really exciting. Marcus Davage is joining us. Hi, Marcus.
Hey,
And we're going to have fun today. I have a very quick agenda to get us to our presentation, so I'm going to go ahead and get us underway. Just during today, if you're having any technical difficulties, I hate to give you the simple IT answer, but turn it off and turn it back on seems to work the best for Zoom. So just, unplug it, plug it back in type situation, leave and come back. Please stay on mute. During our Q&A after the session, you can probably come off mute if you have a question that requires some extra additional explanation, but otherwise we appreciate your mute status for our session today. So I hope you can see my screen. I mentioned our introduction and presentation. We had a partnership opportunity, so I think you might have seen IntelliMagic has been the sponsor of this session for quite a while, but this is a virtual user group and our user group has some sponsorships available. So if you are interested in the opportunity to partner with us, you can reach out to me. I'm easy to find at Planet Mainframe. You can literally do amanda@planetmainframe.com or drop me a private chat here today, and I can tell you about that opportunity. I wanted to give a shout out and say you can come see us if you're going to be at Share in about, 5-6 weeks. We are going to be at Share in DC. There we are going to launch the influential mainframer nominations. And if you may remember that program last year, we picked 40 influential mainframers to celebrate. We're going to open those nominations. We're also going to release the 2025 Arcadi Mainframe Navigator, which is the yearbook, user survey, and directory for Arcadi. And lots of fun prizes. And I don't want to spoil the surprise for our booth. So if you're at Share, come by and say hi and check us out. After today's session, you'll get a really brief exit survey. If you take a moment to answer those 2 questions for us, I'd really appreciate it. And for Q&A today, we'll do Q&A after the presentation. So you can hold your questions, verbally hold your questions. If you want to drop them in chat along the way, I'll take care of holding those and make sure Marcus answers them later. So that way you don't have to worry about forgetting your question. But that's what we're going to do for Q&A today. And with that, we're ready for claims, drains, and automobiles. So I'm going to stop my share and let Marcus get his going while I introduce him. So Marcus graduated computer science in 1990 and has worked with mainframes ever since. He's been a programmer, systems programmer, consultant, database administrator, production support villain, management pinata, user group chairman, international conference speaker, and is now a lead product developer for BMC Software. He's a STEM ambassador and works a lot with junior schools, code clubs, and supports the next generation of tech. So Marcus, excited to have you here today.
thank you very much, Amanda. What a lovely welcome. And it's great to see so many old friends and current friends and colleagues in the participant list. Yeah, thanks for coming. So, claims, drains, and automobiles says a lot about the kind of films that I watch. I just basically threw all of the agenda into a Wordle cloud, and this is what it came up with. So this is what we're going to be talking about for the next hour or so, maybe, or hopefully less. So you can go back to your lunch or tea. So let's dive in. So picture a bustling metropolis. Thousands of people crossing the streets, driving cars, getting to work. Without traffic lights, police officers, or laws, it'll be absolute chaos. For DB2, that metropolis is data and transactions and utilities and queries and units of work. Claims, drains, locks, and latches are the silent traffic controllers that keep the peace. So we look at claims, drains, locks, and latches. Claims say who has access to what. Without them, we have mayhem. Drains is how do we make sure that the road is clear? Without them, we have gridlock. Locks means can two people update this at once? Without that, we have data corruption. And latches, can we safely manage control structures? Without them, we get a crash. So let's break these down and try and make sense how they work and why they matter, and try and have some fun in the process. So let's look at claims. Claims is a mechanism that controls access intent on a physical page set. So basically a DIBS. In the UK, we call it Bagsy, but I had to have this translated. Basically, DIBS is American for Bagsy. So who can make claims? Db2 utilities can. Db2 commands can. And some statements like create, alter, and drop, they can take control of the Db2 object that uses a claim. What does this apply to? Well, basically any object with a vsum file underneath. That would be a non-partitioned or a partition table space, the data partitions of a table space, a non-partition index, or index partitions. What is a claim? Well, it indicates an interest in a page set or in a partition. It's independent of transaction locks, and it prevents drains until a claim is released. When do claims occur? Well, within a unit of work. It starts upon first access of an object, and it lasts until the next commit point. Unlike a transaction lock, a claim normally does not persist past the commit point. To access the object in the next unit of work, the application must make a new claim. A claim indicates activity on or interest in a particular page set or partition to DB2, and claims prevent drains from occurring until the claim is released. There are three types of claim class. We have the write claim, which allows reading, updating, inserting, and deleting. A repeatable read, which allows reading only, but with repeatable read isolation. And a cursor stability read, which allows reading only with read stability, cursor stability, or an uncommitted read isolation. Db2 generates a trace record for each time period that a task holds an uncommitted read claim. The value of the long-running reader field, the LRDR-THLD subsystem parameter, controls the length of time, the length of that time period. Db2 also issues a warning message, DSNB 260I, when a trace record is written. And I'm sure you've seen plenty of these in your subsystem log. So I've taken the decision to throw some judicious AI images to try and spice up this otherwise dry presentation. So I'd like to go back to our metropolis analogy. A claim comes into play when a road needs digging up or relaying. Having pedestrians or traffic meandering up and down while pneumatic drills are in operation or molten tar is being poured doesn't bode well for the road or for the user. So claims matter when utilities like reorg that need exclusive access to the page set, commands like stop and start, SQL statements like drop, alter, and create. So these are claims, and I shall explain with an illustration of what goes on a little bit later. A drain is basically a clear off command or instruction. So imagine your table space is a cafe. The owner wants to close up and clean the cafe, aka a reorg. He puts up a closed sign. That's the drain lock. The current customers need to finish up and leave. No more customers are allowed in. And once the cafe is empty, the work begins. So, if a claim indicates activity in a Db2 page set or partition, taking access of objects within a unit of work and releasing them at the next commit point until an existing claim is released, then it can prevent drains from being obtained. A drain then takes control or access of a Db2 object by preventing new claims and waiting for existing claims to be released. For example, the check index utility needs to drain only writers from an index space and its associated table space. A recover, however, must drain all claim classes from its table space. The reorg utility can drain either writers with the drain writers option or claim classes with the drain all option. So a drain lock prevents conflicting processes from claiming or draining the same object at the same time. A drain lock also prevents new claimers from accessing an object while a drainer has control of it. The types of drain locks correspond to the following claim classes, and I mentioned those before. These are write, repeatable read, and cursor stability read. To drain an object, a drainer first acquires one or more drain locks on the object, one for each claim class that it needs to drain. When the locks are in place, the drainer can begin after all processes with claims on the object have released their claims. When the claimer gets the drain lock, it makes the claim and releases the lock before beginning its processing. So those are a lot of words and no real idea, no real concept of what's going on. So here's an example. So this is a simple example where multiple applications update a single table space. We have two applications, A and B. They're working in a Db2 system where a table space exists that's affected by both applications. Application A requests a claim to update the Db2 object. Say he wants to do a load. Since there is no existing claim or drain on the object, application A gets the claim. Application A then drains the object. Application B is processing without any need to access the Db2 object at this time. While application A updates the table space, it's now time for application B to get access to Db2. So at this time, application B requests a claim. Application A holds the drain on the Db2 table space. So application B can't get the claim, so it waits. Application A finishes with the updates and starts to release the drain. Meanwhile, application B is still waiting for the claim. Once application A releases the claim, application B is then able to obtain a claim. Once application B has the claim, it can drain the object. Ooh, there we go. Application B can then update the Db2 table space as needed. Once it's complete, the drain is released, followed by the claim, and ta-da, everything's back to normal. So those are claims and drains. What about locks? Locks are basically a hands-off instruction. Locks prevent concurrent transactions from corrupting data. They ensure consistency across and within transactions and guarantee data integrity. The three properties important to understand in lock-in are their size, their duration, their mode, and their type. The size describes the amount of data that is controlled by the lock. The duration is the length of time the lock is held. This varies according to the lock. Then the lock is acquired and released. The mode of the lock tells what access to the locked object is permitted to the lock owner and any other interested concurrent processes. So size really does matter when it comes to locking. Locking larger or smaller amounts of data allows you to trade performance for concurrency. Using page or row locks instead of table or tablespace locks has the following effects. Concurrency usually improves, meaning it's better response times and higher throughput for many users. Processing time and use of storage increases. This is especially evident in batch processes that scan or update a large number of rows. Using only table or tablespace locks has the following effects. The time processing and storage used is reduced. Concurrency, however, is also reduced, meaning no longer response times for some users, but better throughput for one user. It's a trade-off. Everything is. So imagine your tablespace is a library. A tablespace level lock takes very little time, very little CPU and IRLM storage. And for low usage or small table spaces, it would be absolutely fine. But for very large or busy table spaces, libraries, this would severely impact other users, as they would have to wait for you to finish reading your book until they were let in. A page level lock. So imagine your table space is a library. Everyone is allowed in, but no one else can use your desk while you're using it. And finally, a row level lock. In your table space, which is a library, everyone's allowed in and everyone is allowed a book. The downside of this is cost and performance. Db2 uses the lock mode to determine whether one lock is compatible with another. Some lock modes don't exclude all other users. For example, assume that application A holds a lock on a table space that application B also wants to access. Db2 requests on behalf of process B a lock on some particular mode. If the mode of the lock for process A permits the lock requested by process B, the modes of the two locks are said to be compatible. However, if the two locks are not compatible, process B cannot proceed. It must wait until A releases its lock and until all other existing incompatible locks are also released. So let's have a look at the different page row lock modes before we get on to the table space and table lock modes. A share lock means that the lock owner and any concurrent process can read but not change a locked page or row. And remember, we're talking about pages and rows, not tables or table spaces yet. Concurrent processes can acquire S or U locks on a page or row that might read data without acquiring a page or row lock. Only one U lock can be acquired concurrently with one or more S locks. With an update lock, a U lock, the lock owner can read but not change the locked row or page. Concurrent processes can acquire S locks or might read data without acquiring a page or row lock, but no concurrent processes can acquire a U lock. U locks reduce the chance of deadlocks when a lock owner is reading a page or row to determine whether to change it. The owner can start with the U lock and then promote the lock to an X lock to change the page or row. That's called lock promotion. The lock owner can read or change the locked page or row with an X lock. A concurrent process cannot acquire S, U, or X locks on the page or row. However, concurrent processes, such as those processes bound with current data no or isolation level UR, they can read the data without acquiring a page or row lock. So let's have a look at the compatibility matrix. So this is basically what I've said, but in a table. Now let's move up a step to partition or table space lock modes. Now here we have a lot more options available. When a page or row is locked, the table partition or table space that contains it, is also locked. This intent lock indicates the plan that the application process has for accessing the data. In that case, the table partition or table space lock has one of the intent modes, either IS for intent share, IX for intent exclusive, or SIX for share with intent exclusive. So let's drill down on each one of these. Here, the lock owner can read the table, partition, or table space, but not change it. Concurrent processes can both read and change the data. The lock owner might acquire a page or row lock to any data that it reads. With an IX lock, the lock owner and concurrent processes can read and change the data in the table, partition, or table space. The lock owner might acquire a page or row lock on any data it reads, but it must acquire one on data it changes. Share lock, the lock owner and any concurrent processes can read but not change data in the table, partition, or table space. The lock owner doesn't need page or row locks on the data that it reads. Oops-a-daisy. With a U lock, an update lock, the lock owner can read but not change lock data. However, the owner can promote the lock to an X lock, and then it can change the data. Processes concurrent with the U lock can acquire S locks and read the data, but nothing can acquire a U lock. The lock owner doesn't need page or row locks because it already has the relevant page set locks. Here with an SIX, the share with intent exclusive lock, the lock owner can read and change the data. Current processes can read data but not change it. But when the lock owner changes data, it acquires a page or row lock. And finally, we have an X lock. The lock owner can read or change data in the table, partition, or table space. Concurrent processes can access the data if the process runs with UR or it's in a partition table space and is running with CS isolation and current data no. And the lock owner doesn't need page or row locks because it already has an exclusive lock on the entire table space. And here's our compatibility matrix. So the following table shows the compatibility of any two modes for page and row locks. No question of compatibility arises between page and row locks because a partition or table space cannot use both page and row locks. So I've mentioned isolation levels. So let's drill down and open up what that means. The isolation level CS, or cursor stability, allows maximum concurrency with data integrity. Under the CS option, a transaction holds locks only on its uncommitted changes and on the current row of each of its cursors. Uncommitted read allows an application to read while acquiring few locks at the risk of reading uncommitted data. The UR isolation applies only to the following read-only operations: select, select into, or fetch from a read-only result table. So you can read through somebody else's lock while they're updating a page, but if for whatever reason they decide that they want to roll back or undo, then you could potentially read incorrect data. Read stability enables an application to read the same pages or rows more than once, and it prevents updates or deletes to qualifying rows by other processes. However, other applications can insert or update rows that did not satisfy the search condition of the original application. And finally, we get isolation RR, or repeatable read. This allows the application to read the same pages or rows more than once without allowing any update, insert, or delete operations by other processes. All accessed rows or pages are locked, even if they do not satisfy the predicate. Under isolation RR, the data that an application references cannot be updated by any other application before the application reaches a commit point. So let's go back to our AI-generated images for a little bit of an illustration. So this is an uncommitted read. Looks a bit creepy, and she might change her mind. So he might be reading incorrect data. A lock is basically a hands-off instruction. No one gets to read a book that somebody else is about to update or delete, and no one scribbles notes in the margins of a book that somebody else is reading. That can be a little disruptive and just downright rude. So how do you apply these locks? Well, when you're binding a package or a plan, you specify the release statement or the release parameter. Release deallocate provides an opportunity for better performance for many applications, but with worse concurrency. Release commit is greater concurrency, but a higher CPU time. Isolation levels, that's another bind parameter. I've already mentioned those. Cursor stability, uncommitted read, read stability, and repeatable read. The current data option, which I've just ignored. The current data option, isolation level CS and current data no. This enables Db2 to release locks early and avoid taking locks in many cases. Isolation level of CS with current data yes reduces the risk of non-current data being returned to the application. However, the trade-off is a reduced ability for multiple applications to access the same data concurrently. A new bind parameter is called concurrent access resolution. And the values for the concurrent access resolution parameter are use currently committed or wait for outcome. Oh, come on, IBM. You could have shortened that. That's a bit of a mouthful. So when you use currently committed, the application process can access currently committed data rows that are locked by uncommitted insert or delete operations without waiting for a lock contention to resolve. But if you specify wait for outcome, the transaction waits for the locks that are held to be released. There you go. And another way of affecting locks is by using SQL. You could use the lock table partition or in share mode or exclusive mode. You could also, in your create DDL, use lockmax. That specifies the number of page or row locks an application process can hold in the table space. If a program requests more than that number, then the locks are escalated. All page row locks are released, and the intent lock on the table space is promoted to an S or X lock. If the lock size is table space, lockmax must be omitted or its operand must be 0. Also, the lock size can be any table space, page, or row. This specifies the size of the locks used within the table space, and in some cases, also the threshold at which the lock escalation occurs. And you could also use SQL. So we've got select columns from table with UR, with CS, with RS, or with RR. So there are issues I've mentioned before. It's a trade-off. So here are some issues that we get with locking, lock promotion, escalation, suspension, timeouts, and deadlock. So lock promotion. Lock promotion is the action of exchanging one lock on a resource for a more restrictive lock on the same resource, held by the same application process. So, for example, an application reads data. It requires an IS lock on a table space. Based on further calculation, the application updates the same data, which requires an IX locks on the table space. The application is said to promote the table space lock from mode IS to mode IX, making it more restrictive. The effects of this are that when Db2 promotes the lock, it first waits until any incompatible locks held by other processes are first released. And then when locks are promoted, they are promoted in the direction of increasing control over resources. So from IS to IX, from S or X. Sorry, start again. From IS, intent share, to IX, intent exclusive, S, shared, or X. If you're on IX, that's promoted from to SIX, or X for exclusive. If you're on S, that can only be promoted to X. If you're on U, that can only be promoted to X. And if you've got an SIX lock, that too can only be promoted to X. So there are some rules that Db2 follows when it promotes locks. Lock escalation. So yeah, we've got, it's all happening in this office. Something's escalating. Lock escalation is the act of releasing a large number of page, row, lob, or XML locks held by an application process on a single table or table space in order to acquire a single table or table space lock or set of partition locks of mode S or X instead. So let's go through that again. If you've got a bunch of locks on a bunch of rows or pages, and the number of locks tips the threshold, Db2 releases them all and promotes that lock, or escalates that lock rather, to the object itself. So a lock escalation balances concurrency with performance. When lock escalation occurs, it varies by table space, depending on the values of lock size and lock max. Lock escalation is suspended during the execution of SQL statements for alter, create, drop, grant, and revoke. And as a rough estimate, if 1/4 of your lock escalations cause timeouts or deadlocks, then an escalation is not effective for you. You might need to alter the table to increase lock max and thus decrease the number of escalations. Alternatively, if lock escalation is a problem, then use lock max 0 to disable lock escalation altogether. I asked my friendly AI, how would you represent suspension? And so it's got somebody being suspended from a suspension bridge. I quite like that. So what is lock suspension? An application encounters suspension when it requests a lock that is already held by another application process and can't be shared. This suspended process temporarily stops running. A suspended process resumes when all processes that hold the conflicting lock release them, or the requesting process experiences a timeout or deadlock, and the process resumes and handles an error condition. An application process encounters a timeout when it terminates because of a suspension that exceeds a preset interval. Db2 terminates the process, issues messages, and returns error codes. For example, an application process attempts to update a large table space that's being reorganized by a reorg with share level none. It's likely that the utility job doesn't release control of the table space before the application process times out, and that's what the timeout is. A deadlock occurs when two or more application processes Each hold locks on resources that the others need and without which they cannot proceed. After a preset time interval, Db2 rolls back the current unit of work for one of the processes or requests a process to terminate. In determining which process to roll back or terminate, Db2 assesses many characteristics of the processes that are involved in the deadlock and chooses the one that, if terminated, will cause the least impact relative to the other processes. By choosing a process to roll back or terminate, Db2 frees the locks and allows the remaining processes to continue. A latch, however, is a lightweight, short-duration synchronization mechanism used by Db2 for internal structures. Unlike locks, latches are for system resources and not data. They are critical for high-speed control of things like buffer pools or index updates. Always within a single subsystem, Db2 or IRLM, or a single member. If you need to serialize something across data sharing groups, a global lock will be used. There are only two states, which is X and S, on a latch, and they are typically a very short duration. Acquire the latch, do whatever needs to be done, and then release it. For example, get latch for a Db2 storage pool. Acquire the storage you need, and then release the storage pool latch. If the latch is not available, the request of the latch is queued. That can lead to latch contention and be a serious performance bottleneck. So once again, these are for system resources, not data. It's critical for high-speed control of things. And if you want more information on this, just have a look at Bart Stegman's presentation on the IDEG content pages for considerably more detailed information than this. So, use your subsystem performance monitors to detect things like latch contention and lock suspension. You can use application performance monitors to detect and report on deadlocks and timeouts. You can issue the -display command to investigate deadlocks and timeouts with the use, claimers, and locks keywords. And make sure your utilities are tuned with the right parameters for the right time of day and the right lock-in requirements. For example, you can run a share level change reorg at any time of the day, but delay the switch phase to a quiet period, for example. And try and use lock avoidance techniques where possible. Use row-level locking, uncommitted read isolations for read-only transactions, if that's appropriate, and just go through the loop of monitor, measure, tune, and repeat. Otherwise, you'll just be in trouble with pedestrians and cars and buses and trucks and everything. And that, ladies and gentlemen, is mostly it. Claims are polite requests to use the data. They allow concurrency while protecting against chaos. Drains lets utilities take over table spaces safely. It's about clearing the way. Locks keep your data safe. They prevent overwrites, corruption, and chaos. Latches keep internal Db2 operations humming along at lightning speed. Choosing the right isolation level for your application balances performance and consistency. But remember, the golden rule is monitor, measure, tune, and repeat. That, ladies and gentlemen, was that. Claims, drains, and automobiles. Do we have any questions?
I see a couple of questions already in the chat, Marcus.
Okie dokes. So,
Do you want me to read them?
yeah, I can see those.
Oh, okay.
So Michael asks, does DML make claims? The slide implies only DDL. No, DML doesn't make claims. So DML, data manipulation language, that's insert, update, and delete. They don't use claims because they don't need to access the underlying vSAM object. All of the DML, select, update, insert, delete, is handled by the RDS, the relational data server in DB2, and the locks for that are handled by the locking mechanisms, not claims and drains. Michael asks, unlock without commit, set rather SQL statement for selecting into variables with UR. Not quite sure what that question means. Michael is more than happy to. I'm more than happy for you to unmute and ask, pursue that question. Two different questions. So, can you unlock without commit? You can hold locks over a commit, but you can release your locks by doing a commit or a rollback. I think those are the only two ways you can release your locks. I'm sure Dave was on earlier. He could have answered that. Set rather than select SQL statement for selecting into variables with UR. I think that's possible. I'd have to check. Are there best practices? Asks Charles, relative to setting locks. Yes, there are. And I think that's a topic for another presentation. That's called lock avoidance. So it's a balancing act between defining your table space, whether with page level locking, row level locking, or table space level locking, and your applications running with the different isolation levels. Yeah, I think what I'd like to do, if Amanda's okay with this, is I'll do a bit more research and I'll come and do another presentation at a future time on lock avoidance. So watch this space, keep tuning into Planet Mainframe, and we'll let you know.
Sure. Are there any other questions? I lost my screen. Hold on.
I think that was it.
All right, great. Well, for me, I've got some social media links I will share with you real quick. I think you're seeing my screen. Marcus, thank you so much for the presentation. And we will definitely have you back. You're one of my favorite DB2 presenters for this group.
Oh, shucks.
Yeah,
thanks.
Always a great session. And I'm sure if you haven't yet and you're ever at a conference where Marcus is speaking, it's a session you want to check out and tap into. And sorry, I'm trying to pull up my next meeting dates for you, but having a little bit of multiple screen issues. One moment, please. So we will see you in 2 months. Our next session is going to be on the 18th of March. So 3/18, we'll see you in a couple weeks. And in the meantime, I hope you're subscribed to the newsletter so that we can send you information in the recap from this event. And you can always attend any of our other sessions. We have a KICS and an IMS user group as well. And I should mention, since we are in our DB2, so Planet Mainframe will also be at iDoug in Atlanta in June, and that's my hometown. So I hope to see as many of you there as possible. Reach out to me, and we'll find a good place to go grab a beer while y'all are in town. With that, thank you again, Marcus, and we'll see you all in a couple months.
You're welcome. Have a great week.
You too. Bye.